Hello everyone, my name is Zhicheng Huang. I come from Taiwan Chaoyang University of Technology. My topic is the influence of the angle of feature point for indoor positioning by machine vision. This is my outline. Introduction. In the previous work, 3D scanner is used to obtain non-environmental features, and image processing technology is applied to achieve positioning function, but did not further analyze the accuracy of this method. In this paper, we will experiment with the proposed indoor positioning technology to understand the influence of its positioning. Indoor positioning method. Our camera is placed indoors and overlooked from the top to down. There are four feature points: F1, F2, F3, and F4. On the four walls, every two of these four feature points came from a circle with C. The angle between the sum of these two angles is the angle between the F1 direction and the F2 direction. When the location of F1 and F2 with the angle are known, the location of the camera can be R1, R2, R3, and any point on the circumference. A circular equation can be obtained by any two feature points captured by the camera. The possible position of the camera is on this circumference. We can get an intersection every two circles. In our example, we can get four intersections as denoted with C1, C2, C3, and C4 in Fig 2. The average of these four positions is the camera position, which is positioning result. Simulation space, experimental, and result. We made a space of 90 cm times 60 cm times 30 cm, the simulation space. Four colors on the four sides of this space are used as feature points. The camera we used is Reseta S, which is a camera that can take panoramic views. We placed the camera in two locations in the simulation space are points A and B. Each position of the camera should image in two directions, and the image of four directions A1, A2, B1, and B2 can be obtained. We can easily find out four feature points for the four images by color features. The angles is set as estimate by the four images to each feature point are shown in Table 1. We can see that when there are an angle is large, the error will be increased. Real space, experiment, and result. This space is room M218 of Chaoyang University of Technology. with a space of 7.1 meter times 6.8 meter. The location of the 4 colors papers are known. We randomly take 2 locations of the camera in this space as shown with point 1 and point 2. We shot 9 images in each position. We will adjust the camera's shooting image in each time we shot an image. Each image is calculated by the proposed method to obtain the angle of each feature and the positioning arrow. From Fig 6, we can see that there are 2 arrows greater than 20 centimeters, where each feature point has an angle greater than 72 degrees, and another feature point angle greater than 52 degrees. In 3, one angle is greater than 72 degrees, but the other 3 angles are less than 40 degrees. In 8, there are 2 angles greater than 75 degrees, but the other 2 angles are less than 30 degrees. From Fig 7, only the arrow of 4 is greater than 20 centimeters, where there are 2 feature points have angles greater than 73 degrees, and even one of them over 80 degrees. Conclusion: according to the experimental results of the simulation space and the real space, we know that the angle between the feature direction and the camera shooting direction will affect the accuracy of the positioning. The image taken by the fisheye camera will be distorted and reduce the resolution. Especially when the object is at the edge by the image. In the case that there are enough feature points, the feature points with large angles can be discarded to improve the accuracy. At the same time, if we can understand the distortion feature of the fisheye lens, we can also improve the positioning accuracy. Thank you for your listening.